Hello dear students, in this video we are going to talk about the real sequences. It's a unit for second B.Sc, third semester, that the unit 1, the real sequences. You must have heard the word the sequences because you studied sequences in your lower classes, sequences. So you have seen so many problems in the sequences, and let's see what is the definition of the sequence. Basically, sequence is a function. We are saying it's a function. When you heard a function, it must have a domain. It must have a domain, and along with domain, you might have heard another word, codomain. And in codomain, you have range. The three words, the familiar with the function. The three words are familiar with the function. So basically it is a function, sequence. The sequence is a function. We'll denote it as a sequence in a flower brackets. Yes, n. Yes, subscript n. The curly brackets inside. So it's a function. It's a function whose domain. We have to talk about the domain. Here the domain is set of natural numbers. Set of natural numbers. N. Set of natural, we'll denote it by the letter, English letter n. Set of natural numbers. And the range, when you talk about the range may be any set. Range is any set. Any set. Let me call it as R. So basically a sequence is a function whose domain is a set of natural numbers. That's important. You have to choose the element for what is the domain. Domain is a set of all possible for the given function. So we have to choose the element for the function. For the sequence from the natural number set only. You cannot choose from the real number set or any other set. So range may be in. It's based on the how we define the sequence. So in other words, we can say the sequence in a set S is a rule which assigns to each natural number a unique element of S. So sequence in a set S is a rule which assigns to each natural number in a unique element of S. We know that a function we have seen in a function, we are getting the each unique image in a codomain set. Okay, where the mapped element, the set of all mapped element of the domain is called as a range of the set. Okay, if we talk about the range, if the range is subset of real numbers, the range is subset of real numbers, that is S is a subset of real numbers, then your sequence is called real sequences. Then your sequence is called real sequences. If you are the range set is if you are getting the real range set as a subset of real numbers, that may be rational numbers, irrational numbers, or maybe integers, or maybe a natural numbers, even maybe a natural numbers. So such a sequences are called real sequences. So we generally denote the sequence. We said that it's a function from set of natural number to the any set. Range set is any. So if we see, so we have said that here if your subset range is a subset of real numbers, then that is such a sequences are called real sequence. So in symbolically we write so yes, from n to S is a function from n to R, or we can use the notation f from n to R, or we can write the notation as n to R. But in the syllabus we are talking about the real sequences only, so we can use this notation. That means S from n to R. So it's a real sequence. Okay, let us see the notations of. So you said that S is from n to r be a sequence, if s from n to r be a sequence, the image the image the image of n, so n is, you have to choose from set of natural numbers only, so we can write in image of that as s1, s2, s3, so on, of natural numbers, right? These are the what image of natural numbers. See, you take, this is a set of natural number, and this is your range set, which is a subset of R. So if you define a Sn as, let me take Sn for example, let me take as Sn as n square. So you have to, your domain is 1, 2, 3, 4, so on. What are the image of 1? 1 is 1 square, so that is 1, which is the first term, s1. So for n is 2, 2 square, that is 4, this is s2. And for 3, 3 square, this 9, this is s3, so on. We are getting a unique image. So these are these elements are, we can say it as s1, s2, s3, so on. Okay, natural numbers, this is 1, 2, 3, right? So you see the first natural number, second, third, fourth, the image of the image, like this, called the, so these are called the what, s1, s2 are called the elements or the terms of the sequence. These s1, s2 are called s1, s2, s3 are so on, are called terms or elements, of the sequence, right? Okay. So where s1 is called the first term, the values of this, so the values here is, see, 1, this is called, see, you have 1, 4, 9, so on. This is s1, this is s2, s3, these are the values, right? So this is the first term of the sequence, this is the second term of the sequence, this is the third term of the sequence, like that. You have seen these all things in your earlier classes. There is no special things in here. So okay, and one more thing, that if the, you know that what is the nth term and all. So if the nth terms of sm and sn for m not equal to n, are treated as distinct elements, okay, distinct terms, even if sn is equal to sm. So even if, see, if the values of the mth term and the nth term are equal, the position are different, right? So for example, if you have s5 is 4, so s8 as 4 again, so this is, if I take m and this is as n, see, the values of the terms are same, the values of the sequence, the terms are same, but their position different. The fifth term is 4, whereas the eighth term is also 4, so we have to treat them as a different terms, distinct terms. We have to treat it as distinct terms of the distinct, even if sn is equal to sm, right? So we can say that the terms of a sequence are arranged in a definite order. So it's not based on the values of the sequence, it's arranged in a order, based on definite order. Okay, then if I, for example, this, so let me see the examples of the sequences. So Sn is equal to, we are representing your sequence by curly hairs, so that is equal to minus 1 to the power n. This is the example for your sequence. So n belongs to, n has to belong set of natural numbers. So what is the first term? So that is s1. S1 is equal to, you substitute minus 1 to the power 1, you are getting 1. So what is s2? S2, that means n is equal to 2. Here you substitute n is equal to 2, that is minus 1 to the power 2, that is equal to minus 1 to the power 1. So S3 is, you are getting minus 1 to the power 3, so you are getting minus 1, and S4 as 1, so on, so on. So that we are getting only two values here, only two values, two distinct values. Remember this, two distinct values, two distinct. You have to take them as, see your S1, S3. For odd values of n, you are getting minus 1, right? For odd values of n, you are getting it as a minus 1. For even values of n, you are getting positive value. So we are getting the only two distinct elements, only two distinct elements, that are 1 and minus 1. So, and if I take one more example, Sn is equal to 1 by n, where n belongs to n. So see here, S1 is equal to 1, S2 is equal to 1 by 2, and S3 is equal to 1 by 3, S4 is equal to 1 by 4. See here, all the elements are distinct. See, for first for n is equal to 1, for n is equal to 3, for n is equal to 4. Look at this, all the terms are distinct here. Okay, this is all about the sequences. Now we shall talk about the range. The range, what is range? The outcome of the sequence, the outcome value. When you put the value for expression for Sn, you're getting some answer, that is called the range. So we can say the range, or a range set. It's a set, basically the set of the values. So we can take it as a set. The range or the range set is a set of consisting. We can say range set also. Range set. This is the set consisting of all distinct elements of a sequence. All distinct elements of the thing without repetition. We should not consider the repeated terms. If we have repeated terms, we should consider it only once, without repetition and without regard to the position of a term. So it's a consist of all the distinct elements. That's the output of the your sequence. So it has to, without repetition. We should not consider about the repetition, repeated terms. We should not consider the repeated terms, and without regard to the position of the term, whatever the position, how the same terms, how many times it's repeated, we should not take into the consideration. Okay, now let's see the example to understand this definition. See, so let me take this earlier sequence, that is minus 1 to the power n. See, so here S1 is equal to 1, sorry, minus 1. So S2 is equal to 1, S3 is equal to minus 1, S4 is equal to 1. See here, you are getting only minus 1, 1, 1. Repeated, it repeats so many times, minus 1 and minus 2. See, so the range of Sn is equal to, see, only two elements, minus 1, 1. See, it is a finite set, because we are getting only minus 1, because the sequence is minus 1 to the power n. Let me take one more example. Sn is equal to 1 by n. See, we are getting as S1 is equal to 1, S2 is equal to 1 by 2, S3 is equal to 1 by 3, S4 is equal to 1 by 4. So like this it continues. So the nth term is Sn by n. It continues. So the range of this is range of Sn is equal to, see, it is 1 by n, such that n belongs to n, see, nth term. So you have nth term. It continues like that only, 1 by 5, 1 by 6, and 1 by 100, 1 by. So this is your range set. It's not stops. You don't have any repeated value, you have a distinct. If you collect that terms, you are getting 1 by n only. So we are writing in the what in terms of n. Your range is, see, it is infinite. It's an example for it's infinite terms. Doesn't stops anyway. It will not stops anyway. It continues for as you give the value for n. So for a constant sequence, you know what is constant sequence. Constant sequence, you have only one value. So Sn is equal to k. We are defined as Sn is equal to as k. Sn is equal to 5. This is the constant. So for any value of n, you are getting the same value. For any value, if take n is 1000, output is 5 only. N is 2000, your output again is a 5 only. So you won't get any other values for different values of n. So Sn is equal to k. So what is the range of this? So this is k only, right? The range is k only. Output is k only. So this is singleton set. Singleton set. We can note the two things on the basis of the discussion of range of Sn. So we can conclude, we can observe two things. So one is that, so your range may be finite or infinite. Finite set or maybe infinite. See, singleton, it's a finite set. It never be empty. The second thing is, it never be empty. You cannot have a empty set as a range of a sequence. You should have a value, because if you take n, you can give at least one value. That is a constant value. Constant range is, you are getting at least one value. That's so for constant sequence. So for any other sequence, you won't get any empty subset of R, or empty set as your sequence, range of the sequence. So we can say that the range of a sequence is a non-empty subset of R. So these are a non-empty subset of R. This is a -1 and 1 are the non-empty subset of, and here also k is some real value, so it's a non-empty subset of R. So let's move to the discussion on bounds of sequence. Bounds of a sequence. Bounds of a sequence. Bounds of a sequence. Okay. The first definition we are going to study is bounded above sequence. Bounded above sequence. So a sequence Sn is said to be bounded above. Observe carefully the word, the bounded above. You should understand these definitions thoroughly. So we have, based on these definitions, we are going to prove so many theorems. So if there exists a real, if it is when we say the sequence is bounded above, see, if there exists a real number k, let me take it as denoted by k, capital letter A, such that Sn is less than or equal to k for all n belongs to n. ಸೊ ಯಾವಾಗ ನಿಮ್ಮ ಸೀಕ್ವೆನ್ಸ್ ಬೌಂಡೆಡ್ ಅಬೌವ್ ಅಂತ ಹೇಳ್ತೇವೆ, ನಿಮ್ಮ ಸೀಕ್ವೆನ್ಸನ್ನು ನೀವು ಏನು ಲಿಸ್ಟ್ ಮಾಡ್ತೀರಿ ಎಲಿಮೆಂಟ್ ವೈಸ್, ಜನರಲ್ ಆಗಿ ಎಸ್ ಎನ್ ಅಲ್ಲಿ ಬರೆಯೋದಿಲ್ಲ. ಎಸ್ ಎನ್ ಅನ್ನು ಬಿಡಿಸ್ತಾ ಹೋದಾಗ ಎಸ್ಸಿಗೆ 1 ವ್ಯಾಲ್ಯೂ, ಎಸ್ಸಿಗೆ 2 ವ್ಯಾಲ್ಯೂ, ಎನ್ನಿಗೆ 1, ಎನ್ನಿಗೆ 2, ಎನ್ನಿಗೆ 3 ಕೊಡ್ತಾ ಹೋಗುವಾಗ ನಿಮಗೆ ಒಂದು ವ್ಯಾಲ್ಯೂ ಸಿಗ್ತದೆ. ಒಂದು ವ್ಯಾಲ್ಯೂ ಇಲ್ಲಿ ಹಾಗೆ ಮುಂದೆ ಹೋಗ್ತಾ ಒಂದು ವ್ಯಾಲ್ಯೂ ಸಿಗ್ತದೆ. ಆ ವ್ಯಾಲ್ಯೂಗಿಂತ ಮೇಲೆ ಯಾವುದೇ ವ್ಯಾಲ್ಯೂ ಇರೋದಿಲ್ಲ. ಆ ವ್ಯಾಲ್ಯೂಗಿಂತ ಮೇಲೆ ಯಾವುದೇ, ಅದು ಎಂಡ್ ಆಗಿರ್ತದೆ, ಎಂಡ್ ವ್ಯಾಲ್ಯೂ ಆಗಿರ್ತದೆ. ಆ ಎಂಡ್ ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿಗೆ ಎಂಡ್ ಆಗಿರ್ತದೆ, ಅಂದರೆ ಅದಕ್ಕಿಂತ ಹಿಂದೆ ಟರ್ಮ್ಸ್ಗಳು ಇರ್ತದೆ. ಈಗ ಇದು ಕೆ ಆಗಿದ್ರೆ S1 S10 ಆಗಿರ್ಬೋದು, S8 ಆಗಿರ್ಬೋದು, S4 ಆ ಟರ್ಮ್ಗಳೆಲ್ಲ ಇರ್ತದೆ ಅದರ ಹಿಂದೆ. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದು 5, ಇದು 8, ಇದು 12 ಅಂತ ಹೇಳಿ ಇದ್ದಿದ್ರೆ, ಇಲ್ಲಿ ಕೆ ಇದ್ದರೆ ಅದರ ಕೆಳಗೆ ತುಂಬ ವ್ಯಾಲ್ಯೂಸ್ ಇರಬೇಕು. ಅದ್ರ ನೆಕ್ಸ್ಟ್ ಇರಬಾರ್ದು, ಯಾವುದು ಕೂಡ ನೆಕ್ಸ್ಟ್ ಇರಬಾರ್ದು. ಬಟ್ ಅದರ ವ್ಯಾಲ್ಯೂಸ್ ಅಂತ ನಮಗೆ ಇದ್ದರೆ, ಕೆಳಗೆ ಅಂಥ ವ್ಯಾಲ್ಯೂಸ್ ಇದ್ದರೆ ಒಂದು ವ್ಯಾಲ್ಯೂ ತಗೊಂಡು ಫಿಕ್ಸ್ ಮಾಡಿಕೊಂಡ್ರೆ, ರಿಯಲ್ ನಂಬರ್ ಫಿಕ್ಸ್ ಮಾಡಿದರೆ ಅದರ ಕೆಳಗೆ ಟರ್ಮ್ಸ್ ಇದ್ದರೆ ನಿಮ್ಮ ಸೀಕ್ವೆನ್ಸ್ ಇಸ್ ಬೌಂಡೆಡ್ ಅಬೌವ್. ಯಾಕಂತ ಹೇಳಿದರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಅದಾಗಿರ್ತದೆ. ದಟ್ ಈಸ್ ಅ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ. ಅದು ಈಕ್ವಲ್ ಆಗಿರ್ಬೋದು, ಅದಕ್ಕಿಂತ ಲೆಸ್ ದೆನೂ ಆಗಿರ್ಬೋದು. ಆ ವ್ಯಾಲ್ಯೂ ಲೆಸ್ ದೆನ್ ಆರ್ ಈಕ್ವಲ್ ಟು ಎಸ್ ಎನ್ ಆ ಟರ್ಮ್ಸ್ಗಳೆಲ್ಲ ಆ ವ್ಯಾಲ್ಯೂ ಆ ವ್ಯಾಲ್ಯೂ ಆ ನಿಮ್ಮ ಸೀಕ್ವೆನ್ಸ್ನ ಒಂದು ವ್ಯಾಲ್ಯೂ ಆಗಿರ್ಬೋದು, ಅಥವಾ ಅದಕ್ಕಿಂತ ಕೆಳಗಿರಬೇಕು. ಅದಕ್ಕಿಂತ ಲೆಸ್ ದೆನ್ ಆರ್ ಆಗಿದೆ ಅದನ್ನು ಬೌಂಡೆಡ್ ಎಬೌವ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಸೊ ಬೌಂಡೆಡ್ ಎಬೌವ್ ಯಾವಾಗ ಹೇಳೋದು? ಈ ಟರ್ಮ್ಸ್ಗಳನ್ನೆಲ್ಲ ಕಲೆಕ್ಟ್ ಮಾಡಿದರೆ ಏನು ಸಿಗ್ತದೆ? ದಟ್ ಈಸ್ ರೇಂಜ್ ಸೆಟ್ ಯುವರ್. ಸರಿಯಾ? ಈ ಟರ್ಮ್ಸ್ಗಳೆಲ್ಲ ಇರ್ತದೆ ರೇಂಜ್ ಸೆಟ್. ದಟ್ ಮೀನ್ಸ್ ರೇಂಜ್ ಸೆಟ್ ಈಸ್ ಬೌಂಡೆಡ್ ಅಬೌವ್. Range set of the sequence is bounded above. Range set of the sequence is bounded above ಅಂತ ಹೇಳ್ತಾರೆ. ಇಲ್ಲಿ ನಾವು ಮಾತಾಡುವಂಥದ್ದು ರೇಂಜಿನ ಬಗ್ಗೆ. ಸೊ ನೀವು ಟರ್ಮ್ಸ್ ಏನು ಕಲೆಕ್ಟ್ ಮಾಡ್ತೀರ ಅದು ನಥಿಂಗ್ ಬಟ್ ರೇಂಜ್ ಆಗಿರ್ತದೆ. ಸೊ ನಿಮಗೊಂದು ವ್ಯಾಲ್ಯೂ ಸಿಗದಿರಬೇಕು, ಕೆ ಅಂತ ಹೇಳಿದೊಂದು ರಿಯಲ್ ವ್ಯಾಲ್ಯೂ, ಅದಕ್ಕಿಂತ ಉಳಿದ ಟರ್ಮ್ಸ್ಗಳೆಲ್ಲ ಸಣ್ಣದಾಗಿರಬೇಕು. ಹಾಗಿದ್ರೆ ಇಟ್ ಈಸ್ ಬೌಂಡೆಡ್ ಅಬೌವ್ ಆಗಿರ್ತದೆ. ಸಪೋಸ್ ಬೌಂಡೆಡ್ ಬಿಲೋ, ಸೇಮ್ ಹಾಗೆ ಬೌಂಡೆಡ್ ಅಬೌವ್ ಹೇಗಿದೆಯಾ ಹಾಗೆ ಬೌಂಡೆಡ್ ಬಿಲೋ ಅಂತ ಹೇಳಿದೆ. bounded below sequence. So bounded below sequence ಹೇಗಿರ್ತದೆ? So the sequence Sn is said to be bounded below if there exists a real number k. ಸೊ ಕನ್ಫ್ಯೂಷನ್ ಆಗೋದು ಬೇಡ. ಇದನ್ನು ನಾನು ಸ್ಮಾಲ್ ಲೆಟರ್ ಕೆ ತಗೊಳ್ತೇನೆ, ಅದನ್ನು ಕೆ ಯಾವುದು ಕ್ಯಾಪಿಟಲ್ ಲೆಟರ್ ಕೆ ಅಂತ ತಗೊಳ್ತೇನೆ. ಸೊ ವೆನ್ ವಿ ಕ್ಯಾನ್ ಸೇ ದ್ಯಾಟ್ ಯುವರ್ ಸೀಕ್ವೆನ್ಸ್ ಇಸ್ ಬೌಂಡೆಡ್ ಬಿಲೋ. ಸೊ ಏನಾಗ್ತದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ ಎಸ್ ಎನ್ ಇಸ್ ಲೆಸ್ ದೆನ್ ಆರ್ ಈಕ್ವಲ್ ಟು ಕೆ ತಗೊಂಡಿದೆ, ಇಲ್ಲಿ ಉಲ್ಟಾ ಎಸ್ ಎನ್ ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಆರ್ ಈಕ್ವಲ್ ಟು k, small letter k, small letter k, small letter k ಆಗಿರುತ್ತೆ. ಅಂದರೆ ಯು ಶುಡ್ ಹ್ಯಾವ್ ಅ ಲೀಸ್ಟ್ ಎಲಿಮೆಂಟ್. ಸ್ಟಾರ್ಟಿಂಗ್ ಎಲಿಮೆಂಟ್ ಏನಾಗಿರ್ತದೆ ಆ ಸ್ಟಾರ್ಟಿಂಗ್ ಎಲಿಮೆಂಟ್ಗಿಂತ ಎಲ್ಲ ಇದ್ದರೆ ನಿಮಗೊಂದು ಸ್ಟಾರ್ಟಿಂಗ್ ಎಲಿಮೆಂಟ್ ನಿಮ್ಮ ಸೀಕ್ವೆನ್ಸಲ್ಲಿ ಸ್ಟಾರ್ಟಿಂಗ್ ಎಲಿಮೆಂಟ್ ಲೀಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಅಂತ ಹೇಳಿದರೆ ಅದರ ಮೇಲೆ ಎಲ್ಲ ಇರುವಂಥದ್ದು ಸ್ಟಾರ್ಟಿಂಗ್ ಇದು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 1 ಇದ್ದುಕೊಂಡು 2 3 4 ಹೀಗೆ ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಹೋದರೆ ಈ ಸ್ಟಾರ್ಟಿಂಗ್ ಎಲಿಮೆಂಟ್ ಸೀಕ್ವೆನ್ಸಲ್ಲಿ ಇರ್ತದೆ, ಅದಕ್ಕೆ ಇದರ ನೆಕ್ಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಕೂಡ ಹಾಗೆ ಇದ್ದರೆ ಅಂಥ ಸೀಕ್ವೆನ್ಸನ್ನು ಬೌಂಡೆಡ್ ಬಿಲೋ ಅಂತ ಹೇಳ್ತೇವೆ. ಅಂಥ ಸೀಕ್ವೆನ್ಸನ್ನು ಬೌಂಡೆಡ್ ಅಂದರೆ ಸ್ಟಾರ್ಟಿಂಗ್ ವ್ಯಾಲ್ಯೂ ಇರಬೇಕು, ಅಂದರೆ ಮಿನಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಇದ್ದರೆ ದೆನ್ ಇಟ್ ಈಸ್ ಬೌಂಡೆಡ್ ಬಿಲೋ. ಇಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಇದ್ದರೆ ಬೌಂಡೆಡ್ ಅಬೌವ್. ಆ ರೀತಿಯಾಗಿಯೂ ಹೇಳ್ಬೋದು ಅರ್ಥ ಮಾಡಿಕೊಳ್ಳಲಿಕ್ಕೆ. ಸೊ ಇಲ್ಲಿ ಕೂಡ ಹಾಗೆ ರೇಂಜ್ ಸೆಟ್ ಇಸ್ ಇಫ್ ದ ರೇಂಜ್ ಆಫ್ ದ ಸೀಕ್ವೆನ್ಸ್ ಇಸ್ ಬೌಂಡೆಡ್ ಬಿಲೋ. ರೇಂಜ್ ಅಂತ ಹೇಳಿದ್ರೆ ಅಂದರೆ ರೇಂಜ್ ಸೆಟ್ಟಲ್ಲಿ ನಿಮಗೆ ಸಣ್ಣ ವ್ಯಾಲ್ಯೂ ಇರಬೇಕು. ಆ ಸಣ್ಣ ವ್ಯಾಲ್ಯೂ ಇದ್ದು ಅದಕ್ಕಿಂತ ಮೇಲಿರುವಂಥ ಎಲಿಮೆಂಟ್ಸ್ ಇದ್ದು ದೆನ್ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಬೌಂಡೆಡ್, ದ್ಯಾಟ್ ಸೀಕ್ವೆನ್ಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಬೌಂಡೆಡ್ ಬಿಲೋ. ಸೊ ಈ ಬೌಂಡೆಡ್ ಬಿಲೋ ಮತ್ತು ಬೌಂಡೆಡ್ ಅಬೌವ್ ಅನ್ನು ಎರಡನ್ನೂ ಟುಗೆದರ್ ಆಗಿ ಒಟ್ಟಿಗೆ ಇಫ್ ಯು ಟೇಕ್ ಬೌಂಡೆಡ್ ಬಿಲೋ ಆ್ಯಂಡ್ ಬೌಂಡೆಡ್ ಅಬೌವ್ ಟುಗೆದರ್, bounded below and bounded above sequences, same sequence, ಒಂದೇ sequence bounded below and bounded above ಆಗಿದೆ, we can call it as just bounded sequence, just as bounded sequence, bounded sequence. If your sequence is bounded below as well as the bounded above, so then that is sequence is called bounded. So ಹೇಗೆ ಹೇಳಬಹುದು? we should have both the values. So in between smaller value and greater value ಅಲ್ಲಿ ಇದ್ದರೆ, so such a sequence is called bounded sequences. A sequence Sn is said to be bounded if it is bounded above and bounded below. That's a sequence bounded above if there exist two real numbers. So 2 ಇದಕ್ಕೆ bounded below ಗೆ small letter k, bounded above ಗೆ capital A, 2 real numbers ಇದ್ದರೆ, so that such that ಈ ರೀತಿಯ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಇದ್ದರೆ your sequence, then for all n belongs to n, we should, this is important, for all n belongs to n, so such a sequence is called bounded sequence. So let us see the examples ತಗೊಳ್ಳೋ. So Sn is equal to 1 by n sequence, familiar sequences ನಮಗೆ. ಸೊ ಇದನ್ನು ರೇಂಜ್ ಸೆಟ್ ಹೇಗೆ 1 1 by 2 1 by 3 1 by 4 1 by 5 1 by 6 so on ಹೋಗ್ತಾ 1 by 100 ಅಥವಾ 1 by 1000 so on ಹೀಗೆ ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಸೊ ಏನಾಗ್ತದೆ? ಸೊ ಸಿ ಎವ್ರಿ ಎಲಿಮೆಂಟ್ ಆಫ್ ದ ಸೀಕ್ವೆನ್ಸ್ ಇಸ್ ಲೆಸ್ ದೆನ್ ಆರ್ ಈಕ್ವಲ್ ಟು 1. ಹೌದಾ? ಎವ್ರಿ ಎಲಿಮೆಂಟ್ ಇಸ್ ಆಫ್ ದ ಸೀಕ್ವೆನ್ಸ್ ಇಸ್ ಲೆಸ್ ದೆನ್ ಆರ್ ಈಕ್ವಲ್ ಟು 1. ಸರಿಯಾ? ಇದು ಇಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ 1 ಅಂತ ಹೇಳಿದೆ. ಸೊ ಏನಾಗ್ತದೆ? ಇದು ಹೋಗ್ತಾ 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 ಏನಾಗ್ತದೆ? ಝೀರೋಗೆ ರೀಚ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ ನೋಡಿ ನಮಗೆ ಈಕ್ವಲ್ ಆಗಬೇಕಂತ ಹೇಳಿಲ್ಲ, ಝೀರೋ ಅನ್ನುವಂಥದ್ದು ನಮಗೆ ಇದರಲ್ಲಿ ಇರಬೇಕಂತ ಹೇಳಿಲ್ಲ, ನಮ್ಮ ಈ ರೇಂಜ್ ಸೆಟ್ಟಲ್ಲಿ ಇರಬೇಕಂತ ಹೇಳಿಲ್ಲ. ದಿಸ್ ಮೇ ಬಿ ಲೆಸ್ ದ್ಯಾನ್ ಆರ್ ಕೆ ಇಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಆರ್ ಈಕ್ವಲ್ ಟು. ಸೊ ಹಾಗೆ ಹೋಗ್ತಾ ಹೋಗ್ತಾ ಅದು ಝೀರೋವನ್ನು ಅಪ್ರೋಚ್ ಮಾಡ್ತದೆ ನೋಡಿ, 1000 2000 ಹಾಗೆ ಹೋಗ್ತದೆ, ವ್ಯಾಲ್ಯೂ 0 ಪಾಯಿಂಟಲ್ಲಿ ಬರ್ತಾ ಇರ್ತದೆ. ಸೊ ಏನಾಗ್ತದೆ ಇಲ್ಲಿ, ಸೊ ಇವ್ರು ನೋಡಿ ಇಲ್ಲಿ ಎವ್ರಿ ಟರ್ಮ್ ಆಫ್ ದ ಸೀಕ್ವೆನ್ಸ್ ಇಸ್ ಲೆಸ್ ದೆನ್ ಆರ್ ಈಕ್ವಲ್ ಟು 1, ಸರಿಯಾ? ಎಲ್ಲ ಒಂದಕ್ಕಿಂತ ಕಡಿಮೆ ಇದೆ ಇಲ್ಲಿ, 1ಗೆ ಈಕ್ವಲ್ ಇದೆ ಆರ್ ಒಂದಕ್ಕಿಂತ ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ. ಸೊ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 0 ಅಫ್ಕೋರ್ಸ್, ಸರಿಯಾ? ಸೊ ಏನಾಗ್ತದೆ, ನಿಮ್ಮ ಸೀಕ್ವೆನ್ಸ್ ಲೈಸ್ ಬಿಟ್ವೀನ್ 0 ಲೆಸ್ ದ್ಯಾನ್ ಎಸ್ ಎನ್ ಲೆಸ್ ದೆನ್ ಆರ್ ಈಕ್ವಲ್ ಟು 1, ಯಾಕಂದರೆ 1 ಇಲ್ಲಿ ಸೀಕ್ವೆನ್ಸಲ್ಲಿದೆ, 1 ಇಲ್ಲಿ ರೇಂಜ್ ಸೆಟ್ಟಲ್ಲಿದೆ, ಬಟ್ 0 ಇಲ್ಲ. ಬಟ್ 0 ಇಸ್ ದ ಮಿನಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಫಾರ್, ಅಂದರೆ 0ಕ್ಕಿಂತ ಎಲ್ಲ ವ್ಯಾಲ್ಯೂ ರಿಯಲ್ ನಂಬರ್, 0 ಇಸ್ ದ ರಿಯಲ್ ನಂಬರ್. ಸೊ ಉಳಿದೆಲ್ಲ ವ್ಯಾಲ್ಯೂಗಳು ಕಡಿಮೆ ಇದೆ, 0ಗಿಂತ ಜಾಸ್ತಿ ಇದೆ, ಬಟ್ 1ಗಿಂತ ಕಡಿಮೆ ಇದೆ. ಸೊ ಏನಿರ್ತದೆ, ಯುವರ್ ಸೀಕ್ವೆನ್ಸ್ ಎಸ್ ಎನ್ is equal to 1 by n is bounded. Not only just bounded below, not only bounded above, it's both bounded below and as well as the bounded above, so it's called as bounded. So illi nodi, let me take one more example. Sn is equal to minus 1 to the power n 1 by n, so that is equal to minus 1 elements barita hodre 1 by 2, this is nothing but a range, 1 by 3 1 by 4 so on. See ನೋಡಿ ಇಲ್ಲಿ ಏನಾಗ್ತದೆ, ಸೊ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ -1ಗಿಂತ ಜಾಸ್ತಿ ಇದೆ, ರೈಟ್? -1 ಇಸ್ ದ ಲೀಸ್ಟ್ ಇಲ್ಲಿ ಇರುವಂಥದ್ದು, -1 ಇಸ್ ದ ಲೀಸ್ಟ್, ಅದಕ್ಕಿಂತ ಎಲ್ಲ ಜಾಸ್ತಿ ಇದೆ -2 ನೋಡಿ. ಅದು ಕಂಟಿನ್ಯೂ ಮಾಡ್ತಾ ಹೋದ್ರೆ ಹಾಗೆ -1/5 ಆ ರೀತಿ ಇದೆ, ಅಂದರೆ -1ಕ್ಕಿಂತ ಎಲ್ಲ ಜಾಸ್ತಿ ಇರುವಂಥದ್ದು. ಸೊ -1 ಇಸ್ ದ ರಿಯಲ್ ನಂಬರ್ ಸಚ್ ದ್ಯಾಟ್ your Sn is greater than or equal to that. So what is the max, ಇಲ್ಲಿ ನೋಡಿ ಬೇರೆ ಎಲ್ಲಕ್ಕಿಂತ ಎಷ್ಟಿದೆ, ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ 1/2 ಇಲ್ಲಿ 1/2ಗಿಂತ ಮತ್ತೆಲ್ಲ ಕಡಿಮೆ ಇದೆ, ಸರಿಯಾ? -1ಗಿಂತ ಜಾಸ್ತಿ ಇದೆ, 1/2ಗಿಂತ ಕಡಿಮೆ ಇದೆ. ಸೊ ಹೇಗೆ ಬರಿಬೋದು, Sn is less than or equal to 1 minus 1 less than or equal to 1/2 for all n belongs to n in between -1 and 2. So your sequence is bounded. Let me take one more example. Sn is equal to n. See ನೋಡಿ ಇಲ್ಲಿ 1 2 3 4, ಸೊ ಇದು ಕಂಟಿನ್ಯೂ ಆಗ್ತದೆ, ಇದು ಸ್ಟಾಪ್ ಆಗೋದಿಲ್ಲ, ಇನ್ಫಿನಿಟಿಗೆ ಹೋಗ್ತದೆ. ಸೊ ಇಲ್ಲಿ ನೋಡಿ, ವಿ ಕ್ಯಾನ್ ಫೈಂಡ್ ದ ರಿಯಲ್ ನಂಬರ್ ಸಚ್ ದ್ಯಾಟ್ Sn is less than or equal to 1, ಸರಿಯಾ? ಎಲ್ಲಕ್ಕಿಂತ ಕಡಿಮೆ ಇದೆ Sn, 1ಗಿಂತ ಕಡಿಮೆ ಇದೆ, 1ಗಿಂತ ಜಾಸ್ತಿ ಇರುವಂಥದ್ದೇ, ಸರಿಯಾ? 1 2 3 4 5 less than 1. ಸೊ ಇಟ್ಸ್ ಬೌಂಡೆಡ್ ಬಿಲೋ ಇದೆ, ಇಟ್ಸ್ ನಾಟ್ ಬೌಂಡೆಡ್ ಅಬೌವ್. ಯಾಕಂತೇಳಿ ಯು ಕ್ಯಾನಾಟ್ ಫೈಂಡ್ Sn is less than or equal to k, ಯಾವುದಾದ್ರೂ